Okay, so in this lesson, you are going to solve this question that I have on the screen here. It says that we should find the current in the circuit below. So when you look at this circuit here, you see that you have two resistor connections here, and then looking at it, we can't tell directly whether they are in a series connection or they are in a parallel connection. And then before you can find the value of current, you have to know the effective resistance, okay, of this circuit. So how are you going to calculate for the effective resistance of this circuit with this connection that we have here? So let's look at some simple way to do this. Okay, I'm going to teach you some simple way to solve for the effective resistance of this kind of circuit here. So for us to do this, let's look at the paths that has no elements connected in them. Okay, so looking at this path here, we don't have any elements connected in it, and then looking at this path also, we don't have any elements connected in it. So what I'm going to do is that I'm going to name this node here as A. Okay, and then since there's no element connected in between this path, I'll name here also as what? A. And then looking at this path also, there's no element here, so I'm going to name this node here as what? B. And then I'll name this node here also what? As what? Node B. Okay, so with this labeling, we are going to redraw the circuit. Okay, and that will help us to be able to tell whether the resistors are in a series connection or what are in a parallel connection. So let's look at how we are going to do this. So I'm going to write down the node values. Okay, that's I have A, and then I have node B, and then node B. Okay, so now let's continue. So I'm going to redraw the circuit here, okay, using the nodes. So when you look at the circuit between node A and then node A, we have just a path here. Okay, that's a path which has no element in it. So I'm going to draw the path here. Okay, so that's the path between the node A and then node A. And then looking at node B and then node B here also, there is no element in this path here, so I can draw that path here. So here's this path here. And then looking at node A and then node B, you see that we have the 8 ohms resistor connected in between these two nodes. So I'll come here and then look at node A and then node B. Then I can draw this resistor here. Okay, so this is the 8 ohms resistor. And then looking at this node B and then node A here also, you have the 12 ohms resistor in between them. So I can connect it here also. So I have node A here and I have what? Node B here. Okay, so this is the 12 ohms resistor. So I have the 12 ohms resistor here. Okay, so after doing this, you see that we have the voltage source connected in between what? Node A and then what? Node B. Okay, so you can connect the voltage source here also. So this is the 24 volts voltage source. So this is the new circuit that you have drawn here. Okay, it is this same circuit that you have drawn this way. Okay, so when you look at this circuit here, you can tell that the 8 ohms and then the 12 ohms resistors are in a parallel connection. So now you can calculate for the effective resistance easily. So how are you going to do this? So to calculate for the effective resistance, for resistors in a parallel connection, the effective resistance will be that will be the inverse, okay, of each of the resistor values. So that will be 1 over R plus 1 over R2, okay, plus 1 over R3, and then this continuous. Okay, but when you have two resistors, that will be 1 over R will be equal to 1 over R1 plus what? 1 over what? R2. Okay, so from this formula here, I'm going to rewrite this 1 over R here, okay, as what? R to the power of -1. Okay, and this will be equal to 1 over R1 plus 1 over R2. but we know this R here is the effective resistance, okay, and that's the value you want. Okay, you want to make this R the subject, so you will have to get rid of what, this power here, which is what, the negative one here. Okay, so when you get rid of this negative one here, then you can then get the formula to calculate for the what, effective resistance. So now let's look at how we are going to do it. So what I'll do is that I want to get rid of what, this negative one here. Okay, so I'm going to raise both sides to the power negative one. So I raise both sides to the power negative one. So what happens here is that I will have what, negative one multiplying what, negative one, and that will cancel out. So then you have the effective resistance, okay, to be equal to 1 over R1 plus what, 1 over R2, all to the power what, negative 1. So when you use this formula here, you will be able to what, calculate for the effective resistance of what, this circuit. Now let's substitute the values into this formula and then calculate for the effective resistance. Okay, so I have R to be equal to 1 over what, R1. Okay, so I'll take the 8 ohms to be R1 and then I'll take the 12 ohms to be what, R2. So that will be what, 1 over 8 plus 1 over 12 to the power what, negative 1. Okay, so doing this, when you have 1 over 8, 1 over 8 plus 1 over 12, what I'll do is that I'll multiply the denominators. Okay, so that's what, 8 multiplying what, 12, and that'll give me what, 96. And then what I'll do here is that I'll then do cross multiplication. So I'll multiply this 12 here, okay, by this one, and I'll multiply this 8 here by what, this one here. And you know, 8 multiplying 1 will still give me 8, and then 12 multiplying 1 will also give me what, 12. So then I'll have what, 20 divided by what, 96. And then we know what, R to be equal to what, 20 divided by what, 96 to the power what, negative 1. And this will be equal to what, 96 divided by what, 20. So let's convert this answer into decimals. Okay, so that give me a resistance value of what, 4.8 ohms. So that will be the effective resistance for this circuit here. So now that we know the effective resistance, we can now calculate for the current in the circuit. So now let's calculate for the current in the circuit. So from Ohm's law, we know that what, voltage equals current times what, resistance. Okay, and now we want to find the value of what, this current here. So I'm going to divide both sides by the resistance, then I'll cancel out. So then I have what, the current to equal to what, voltage over what, resistance. Okay, so we know the value of the voltage to be what, 24 volts. So that will be equal to what, 24 divided by the effective resistance, which is what, 4.8 ohms. So that will be divided by 4.8. So when I do this, let's see the value of what, the current. So this will give us the current value to be equal to what, 5 amperes. Okay, so that will be the value of what, the current in this circuit. So let's try this question also. So we have to calculate for the battery current and then the equivalent resistance of this circuit here. So looking at this circuit here, okay, with this connection that has been made in this circuit, we can't tell whether the resistors are in a series connection or they are in a parallel connection. So for us to be able to find the equivalent resistance, we'll have to what, redraw this circuit here. So to redraw this circuit here, I'll name the nodes, okay, to which this path that has no element in it as what, node A. And then since there's no element in this path here, I'll name here also what, as A. Okay, and then this node also has this path which has no element in it connected to it. And then due to that, I'm going to name this node as B and then name here also as B since it has no element connected in between. So after naming the nodes, let's use that to redraw the circuit. So I have A here, I have A here, then I have B here, and I have B here. So these are the nodes. So now let's draw the connection. So between the node A and then node A, okay, you see that what I have no element connected in between. Okay, so this is node A and then node A. And then considering this node A and then node B here, you see that I have the 8 ohms resistor connected in between. Okay, so I'll connect the 8 ohms resistor here. So I have the 8 ohms here. And then considering this node A and then node B here also, we have the 4 ohms resistor connected in between. So I also connect it in between node A and then node B. So this is the 4 ohms resistor. And then between this node A and then node B also have the 6 ohms resistor connected in between. Okay, so this will be the 6 ohms resistor. So this is the 6 ohms resistor. And then I have another element between node A and then node B, and that's the 12 ohms. Okay, so let me connect the 12 ohms here also. Okay, let me bring that one up here. So you know this is node A and then this is node B. Okay, so I'll connect the 12 ohms resistor here. See the 12 ohms resistor. And then let me rename this. This is A, this is B. And then you see that the voltage source here, the 24 volt, is connected between node A and then node B. So I will draw this as, so we have the 24 volts here. Then looking at node B and then node B, we don't have any element in between, so I just connect these two. So after doing this, we see that what this circuit tells us directly that all the resistors are in the parallel connection, so you can therefore calculate for the effective resistance, and that will be R will be equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, since we have 4 resistors all to the power of -1. So I'm going to consider this to be R1, this to be R2, this to be R3, and then this to be what? R4. So let's substitute in the values. So that will be what? 1 over 12 plus 1 over 8 plus 1 over 4 plus 1 over 6 all to the power of -1. Okay, so now let's find the value of what the effective resistance for this circuit here. So I'll add all the values in the brackets first. That will be 1 over 12 plus 1 over 8 plus 1 over 4 plus 1 over 6. So that gives me the effective resistance will be equal to what? 5 over 8 to the power of -1. And this will be equal to 8 over what? 5 ohms. So this will be the value for the effective resistance for this circuit. So now that we've calculated for the effective resistance, we can calculate for the value of the current in this circuit here. So now from ohms law, we know that what voltage equals what the product of what current and then resistance. So therefore, when I divide both sides by the resistance, I have what the current to be equal to what voltage over what resistance. I know the voltage given to this circuit is for 24 volts. That what 24 volts divided by what the resistance. So that divided by 8 over what 5. So this will be equal to what 24 times 5 over what 8. So doing this, 24 times 5, that will be 120. And then so that will be 120 divided by 8. So that will give me the value of the current to be equal to what? 15 amperes. Okay, so let's try our hands on this question also. So with this circuit, you have to compute the total circuit resistance and then the battery current in the circuit. Okay, so you have to calculate for the effective resistance and then the current in this circuit. So how are you going to do this? So you can apply the same method as we applied to the previous question here. Okay, so I'll name this node here as node A, and then I'll name this node here also as A, and then I'll name this node as B, and then I'll name this node as what? B. Okay, so from here we can redraw the circuit. Okay, so now let's look at that. So I have node A, and then I have node B, and then node B. Okay, so between node A and then node A, I don't have any element connected between them. And then between node B and then node B also, I don't have any element connected in between them also. Okay, so looking at node A and then B, I have 8 ohms resistor connected in between. So I have this 8 ohms here. And then between A and B also here again, I have 6 ohms connected in between. So I have the 6 ohms resistor connected in between, and then between A and B here also. Okay, A and B, I have the 12 ohms resistor connected in between. Okay, so this is the 12 ohms resistor that I have here, and then we have the voltage source connected in between node A and then node B. So let me bring that one also here. So this is the 24 volts voltage source. So and then you see that what you have all the resistors in the parallel connection. Okay, so you can now calculate for the effective resistance. So you have the effective resistance, okay, to be equal to 1 over R1 plus 1 over R2 plus 1 over what? R3. Okay, I'm going to use this formula here. So that what I will be equal to 1 over R1 plus 1 over R2 plus 1 over what? R3 all to the power what? Negative 1. So now let's substitute in the values. So I make this my R1, I make this R2, and then I mean R2 rather, and then this will be R3. So let's substitute in the values. Okay, so that will be equal to 1 over 8 plus 1 over 6 plus 1 over 12 to the power of negative 1. So let's continue from here. So adding up 1 over 8 plus 1 over 6 plus 1 over 12, that will give me a value of what? 3 over 8. So that will be what? 3 over 8 to the power of negative 1. So doing this, that will be equal to what? 8 divided by what? 3. And then this value in decimals will be equal to 2.667 ohms. Okay, ohms. Okay, so that will be the value of what? The effective resistance for this circuit here. So that means you've answered the first question. The next question was we should calculate for the what? The current in the circuit. Okay, so that's the next question. So how are you going to calculate for this current in the circuit here? So you can apply Ohm's law here, which is what? Voltage equals current times resistance. So you have what? The current to be equal to what? The voltage over what? The resistance. Okay, and you know the voltage is what? 24 volt, and then the resistance is 2.667, okay, ohms. So now let's see the value of what? The current in the circuit. So you have the value of the current to be equal to 8.999 ohms. Okay, and this is approximately 9 amperes. Okay, so that will be the value of what? The current in this circuit.